Hello. What I'm going to do, because I couldn't be here today, is go through helping you guys with lesson number 18. Our objective is students will be able to divide two polynomials when there is a remainder. We haven't really encountered that yet. And so what we're going to do is we're going to look at it in terms of some of the stuff you're familiar with, which would be a mixed number, and go further. So the only vocabulary that we're going to encounter today would be quotient, divisor, dividend, rational number, mixed number, remainder, factor, opposite numbers, and additive identity. I'm going to build upon the video that I had you guys watch for homework when we get down into the actual division part. And so launch, given the graph, determine the equation of the quadratic in standard form. So first things first, I need to make sure I understand that this is in standard form. I know it's quadratic, so I'm picking up on the clues from the problem. And then I might go through and I would analyze the roots, because I know that there is a connection between the roots and factors. The roots that I see so far are x equals -3 and x equals 1. So I list those out. X equals -3 and x equals 1 leads me to have factors of x plus 3 and x minus 1. So those are the associated factors with that. The last thing that I'll need is some point, and I'll look at this one, which looks like the point -1, -3. I'll need some point so that I can figure out the a value of my equation. And so right now I have f of x equals a times x plus 3 times x minus 1. I know that I'm looking at the point -1, -3, and what that really ultimately means is that when x equals -1, y is equal to -3, and we have to remember that y is the same thing as f of x, so this is when x is -1, so f of -1. Okay, so when I do this, I'll have f of -1 equals a -1 plus 3, -1 minus 1. F of 1 we just determined was the value of -3 times a. This gives me +2 times -2, which will be 4. So if I divide both sides by 4, I'll get -3/4 equals a. Now we always go back and reread our question. The question says, given the graph, determine the equation in quadratic standard form. So I'm going to look at this and say f of x equals -3/4. This was a -4. That's a +3/4. Clues that told me that I was incorrect at that moment was the way that both end behaviors point up towards positive infinity. But I have x plus 3, x minus 1, which equals 3/4. X squared plus 2x minus 3, and then I would just distribute that through, and I would get 3/4 x squared plus 3/2 x minus 9/4. So this is f of x in standard form. Okay, just a little warm up. We really need to make sure we understand that process, how we can come up with equations. It's going to help us when we get to the modeling section and we have all those more realistic scenarios where we're working with our graphs, tables, scenarios. All right. Discussion. How do you think you would represent each rational number as a mixed number using the suggested methods? So if I go too fast during this, I suggest you pause, rewind as much as you need, but for sake of time, I'm going to go pretty quickly throughout all of these. And so what I look at is essentially, I have a number line. I start at 0. And that number line is built up from 1, that the denominator is 4, so I'm breaking everything into fourths. And 2, I have to get all the way out to 13. So here's 1/4, 2/4, 3/4, 4/4, and I can view 4/4 as 1. And then I go 5/4, 6/4, 7/4, 8/4, and again, I'll view that as 2, 9/4, 10/4, 11/4, 12/4, and that's 3, and there's 13/4. So that is 3 and 1/4. So that's how you can view this on a number line. Fraction operations, this is something that I like to see, 13/4. If you truly understand how fractions are put together, I have 12 plus 1 makes 13, so that keeps that equivalent, and then I divide by 4. Most people are good going the other direction than what we're about to travel, but essentially what I'm allowed to do with fractional operations is if the denominators are the same, I'm able to add the numerators, right? Well, if you kind of look at that in reverse order, here my denominators are the same, and I could add, well, I can also split them up with the same logic. I can keep the denominators underneath each numerator, and so what this gives me is 3 plus 1/4. As a mixed number, though, we do 3 1/4. Last one, probably most common, would be long division. 4 into 13, that goes into it 3 times. I have 12, I subtract them, and I have a remainder of 1. So there's my remainder. You might have to think back a few years, but we would write it up with the divisor underneath and the denominator, and there's 3 1/4. All right, that's just the warm-up for what we're about to do next. And so here we go. We're going to find the quotient by factoring the numerator. And this first one, what I notice is that I can factor this pretty easily. So I have x plus 2, x plus 1. If I divide by x plus 2, these two expressions make a 1 since they're exactly the same. And what I'm left with is just the expression x plus 1. Now you're probably wondering, all right, if I have a quotient, what I notice is that these two things are not the same, right? This has a 2, which is what made it easily factorable, but this has a 5. And so what you want to do is kind of view this in similar to method 2. And what I can do is I can do x squared plus 3x, and I can break the 5 in essence 2 plus 3. And so the 2 plus 3 equals the 5 that you saw above. And so I haven't really changed anything. I just kind of re-looked at the way I could represent my 5. And I have x plus 2. Well, now if I use that same idea from the previous page, x squared plus 3x plus 2 divided by x plus 2, and I can add into that 3 over x plus 2. I'm allowed to split it as long as I keep my denominators. Well, I know this answer because I did it just to the left, so that's x plus 1 plus 3x plus 2. And so this will be my answer. Now, you might be thinking or wondering, is this some voodoo magic that Mr. Heslop just made up? And you can always check yourself, and I'm only going to do this for the first problem, but x plus 2 goes into x squared plus 3x plus 5. What do I multiply x by to get x squared? But x times x is x squared plus 2x. Subtract each one, so it might be helpful to change pen colors, but this gives me x plus 5. So I have one more, and x plus 2, subtract them. The other thing I like to do is I like to circle things when I've changed them so I recognize it, and look at that remainder of 3, just like we got in our problem. Okay, so hopefully that squashes any concern you may have. The next one, find the quotient by factoring the numerator. What I would notice is this is difference of cubes. It has a special form to it. Difference of cubes is a cubed minus b cubed, and that equals a minus b times quantity a squared plus ab plus b squared. Okay, and so I have here x minus 2 because I know that, do it on the side, but 8 is equal to 2 cubed, and then 2 ends up being my b value, so this would go x squared plus 2x plus 4, all divided by x minus 2. Again, those make a nice 1. Quantities are exactly the same in the numerator and the denominator, and ultimately we really should have a pair of parentheses around that. So my final answer is x squared plus 2x plus 4. How does that relate to the other one? Well, in this case, it's a minus 4, but I really need a negative 8. And so this is really important about making a 0. So it's this additive identity, making a 0. And so ultimately what I need to do is I need to add a negative 4 onto this, because that would give me a negative 8. But if I add negative 4, I really need to balance that out by adding a positive 4. Okay, so this is my side work. Here's ultimately what I would write. X cubed minus 4 plus negative 4 plus 4. And what's really important about this is that this quantity does not change the value at all because it's equal to 0. And I can add 0. And so I would keep my denominator. And right now I am going to regroup. So x cubed minus 8 plus 4 over x minus 2. X cubed minus 8 divided by x minus 2 plus 4 over x minus 2. And then I just did all that work over here, so I'm going to use it. X squared plus 2x plus 4 plus the remainder, x minus 2. And so that's how we can handle some remainders. The other way to do a remainder would be long division. Those are my two favorite ones to look at. When in doubt, you don't need to use inspection, but you should look at long division always. Okay, so what I'm going to do is I'm going to have you guys pause the video, and